Hi, welcome to this video. Here we are going to learn what kind of information a PLC can handle, and how we can store it to later use it in the program. In other words, we will talk about data types and variables. Data types determine how information is stored, interpreted, and processed inside the controller. Choosing the correct data type in a PLC is not just a matter of order. It is essential to optimize memory usage, speed up processing, prevent errors, keep the code clear, and ensure that the entire system communicates consistently. They are important because they help save memory and improve speed, since each data type occupies a specific size in the PLC memory, and using the right one avoids wasting space and accelerates processing. They also help prevent errors by limiting acceptable values and avoiding incoherent data entry. In addition, they bring clarity to the program and ensure compatibility with other devices, making it easier to understand and to achieve correct communication throughout the system. First, let's understand how memory works in electronic devices like a PLC. The PLC processes electrical signals that it interprets as a 0 when there is no voltage, and as a 1 when voltage is present. The value 0 is known as low level or false, while the value 1 is known as high level or true. Everything the PLC executes, whether numbers, letters, or instructions, is represented by combinations of 0 and 1, that is, in a binary system. The smallest unit of information is the bit, which can have a value of 0 or 1. To handle more complex data, the PLC groups several bits into larger structures. A byte corresponds to 8 bits. A word equals 16 bits or 2 bytes. And a double word corresponds to 32 bits or 4 bytes. Basic or primitive data types are the foundation with which a PLC stores and processes information. They are not composed of smaller types and each occupies a fixed size in memory. The BOOL type stores a logical value and can only be true or false. Its real size is 1 bit, although in some PLCs it may occupy more internal space depending on the architecture. It is used, for example, to represent the state of switches, push buttons, or selectors. For integers, there are several variants. The INT type is a small signed integer of 8 bits, which can represent values from -128 to 127. The INT type is a standard signed integer of 16 bits, with a range from -32768 to 32767. The UINT type is an unsigned 16-bit integer, which only accepts positive values from 0 to 65535. Finally, the DINT type is a long-signed integer of 32 bits, capable of handling values from -2147483648 to 214-748-3647. When decimal values are needed, floating-point real numbers are used. Among them are real and LREAL, of 32 and 64 bits respectively, ideal for representing continuous magnitudes such as level, pressure, or temperature. As mentioned before, electronic devices work in a binary system, using only the digits 0 and 1. You might wonder how it is possible to represent integers or real numbers with only 2 possible values. The answer lies in binary combinations. For example, the number 13 in the decimal system is represented as 1101 in binary. If you want us to prepare more content on this type of conversion, leave it in the comments. Special data types are basic but designed to work with particular information related to text, time, and specific events. The string type corresponds to fixed-length character strings stored in bytes and is useful for saving text such as product names or messages for HMI screens. In newer versions, string is used, which employs UTF-8 encoding and allows special characters with multi-language support. The time type, and its derivatives, allow representation of time intervals or date and time stamps. Time occupies 32 bits and is used to handle time intervals. Date uses 16 bits to store dates, and DTL uses 12 bytes to represent complete date and time information. In addition, some manufacturers include additional special types that allow working with system variables or internal device states. Complex or composite data types allow better organization of information and give structure to programs. They are formed from basic or special data types and are useful when sets of related information need to be handled. The array data type is a set of elements of the same type stored in an ordered sequence. It can be imagined as a list of values where all are of the same type, for example a list of integers or a list of Boolean values. The struct data type groups different data types under a single name. It is like a package that can contain integers, reals, character strings, or any combination needed to represent a more complete entity. The UDT type, or user-defined types, are created by the programmer from basic data, arrays, and structs. They are used to build custom structures adapted to the specific application. In summary, basic data represent the simplest unit. Special types allow working with text and time, and composite types offer a more advanced way to organize information in a control program. In a PLC, a variable is a symbolic name that represents data within the program. It can be imagined as a box where information is stored, but the data type associated with that variable determines what kind of information it can contain and how much memory it needs. For example, a variable called motor speed of type INT will occupy 16 bits and can only store integer values within its range. Variables can be classified in different ways. According to their scope, there are local variables that only work within a program block and are useful for temporary calculations or values that do not need to be shared. There are also global variables that can be used in any block of the project, very useful when the same data must be available in different parts of the program, although they should be used carefully to avoid confusion. According to their function in the process, we can talk about inputs, which represent the data that arrives at the PLC from the outside, such as sensors or push buttons. We can also talk about outputs, which are the data that the PLC sends to the process through relays, contactors, or actuators. In addition, there are internal or auxiliary variables, which do not depend on physical hardware and are used for calculations, intermediate states, or logical controls within the program. According to their behavior in memory, there are normal or non-retentive variables that lose their value when the PLC is turned off or restarted, and retentive variables that keep their value even after a restart. The latter are very important in applications that require preserving information such as counters, states, or alarms. It is important to keep in mind that the handling of variables is not necessarily the same in all PLCs. Each manufacturer may have specific rules about how variables are created, stored, or accessed, so it is always advisable to check the manual of the equipment we are using. In this review, we have seen the data types and also the types of variables that allow us to work in a control program. Remember that each variable has a symbolic name and an associated data type, and that its scope determines where and how it can be used within the program. With this, we already have a clear basis to move on to the next topics of PLC programming. To keep learning, don't miss the next video in this series. Click the link that appears here on the screen and let's continue. If you are interested in industrial automation, electrical design, PLC programming, among other topics, I invite you to join the channel by clicking the Join button. By doing so, you will gain access to exclusive content, practical resources, downloads, and materials designed especially for channel members.